Hello guys, and welcome once more to the GC Maths panel. And in this particular setting, which is paper 2 of the bad hand, as we call it, examiner's bad hand, we are going to divide this one into two parts. We have section A, which consists of 15 structural equations, and section B, which consists of 4 essay type questions. So this part will begin with the structural equations. When you take up your paper, don't forget to first of all make sure you fill in all the information. And if you actually enjoy our work, please don't forget to click on the subscription button and to click on the notification so that you don't miss out on any good thing which we are going to present, and you equally encourage our team in this work. Let's begin with the first question of section A. So with this first question, complete the logic table using zeros and ones. Normally, with most of the logic tables you've been completing, you've been seeing F and T. Normally, you can replace the F by 0 and the T by 1. Now, for the first thing we have here, we have A or B. When it's pointing downwards, we call it OR. So the OR is true when one or more of the statements are true. So we have that being filled like that. And the AND statement is the second one. As you can see, the second one, it is actually true only when the two are true. Now A or B implies and is implied by A and B. So how do we do this one? This one means whenever A is true, B is true, and whenever B is true, A is true. So this is what we actually have here. So normally it would be true when all are true. Now question 2, if f of h of x is equal to 5 minus 4x and f of x equals 1 minus 2x, find h of x. Here we see that f of h of x, the composite function, is 1 minus 2 times h of x when you replace x by h of x in this equation. And we will have that to be equal to what has been given. F of h of x is equal to 5 minus 4x. So we see that these two are equal, and we can make h of x the subject. So 5x minus 4x is equal to 1 minus 2 h of x. And this will give us h of x to be equal to 2x minus 2. For the B part of the equation, solve the equation f of x plus x squared minus 4 equals 0. Now that we already have the value of f of x from the equation to be 1 minus 2x, we just replace it here, and you have 1 minus 2x plus x squared minus 4 equals 0. That will give us a quadratic x squared minus 2x minus 3 equals 0, and factorizing, which is easier and faster, will give us x minus 3 into x plus 1 equals 0, and the roots will be x equals 3 or x equals minus 1. Alright, now question 3, we have the 8th term of a sequence is 15 and the 11th term is 6. The 8th term of the sequence is 15 and the 11th term is 6. Find the common difference. So the 8th term T8 is given by A plus 7 times the common difference, which is equal to 15, equation 1. And the 11th term is A plus 10 times the common difference. That gives us 6, equation 2. Since we have been asked to look for D, we can just solve D directly by subtracting equation 1 from 2. And that will give us 10Ds minus 7Ds to be equal to 6 minus 15. So 3Ds equals minus 9 and D equals minus 3. B, what is the first term? We now substitute the value of minus 3 in any of the equations. I have used equation 1 here, and that gives us the value of the first term to be 36. Question 4, find the values of x for which the matrix is singular. Note, a matrix is singular if the determinant of that matrix is equal to 0. And the determinant is given by the product of the leading diagonal, that is x plus 5, and that is x plus 5 times x minus 1 minus 4 times x. That's the product of the leading diagonal minus the product of the off or the reverse diagonal. And this gives us equally a quadratic when we simplify x squared minus 5 to be equal to 0. And from here, x will be equal to plus or minus 5. Question 5. The line L1 is perpendicular to the line L2. And L2 is 3x minus 2y is equals 11 and passes through the points minus 2, minus 1. Note, it is the line L1 that passes through the points minus 2, minus 1. Find the gradient and equation of the line L1. Now that we have been told that the lines L1 and L2 are perpendicular, the first thing to do is to express the line L2 in the gradient intercept form y equals mx plus c. So when I solve for y in line 2, I will have y to be equal to 3 over 2x minus 11 on 2. Now for perpendicular lines, the product of their gradients must be equal to minus 1. So this actually gives us the value of m1, that's for the line 1, to be equal to minus 1 divided by the gradient of the line 2, giving us minus 2 on 3. So that's the gradient of the line L1. And the equation of the line L1 will be given by in gradient intercepts form, or using the normal procedure of a line that passes through one point with gradient m. You have y will be equal to m into x minus x1 plus y1, where x1 and y1 actually represent minus 2 and minus 1 here. So when you substitute these values, you have y equals minus 2 on 3 into x minus minus 2 plus minus 1. And you can further simplify to leave it in gradient intercept form. Question 6. A transformation T maps the points 4, 2, 4, 4 and 0, 4 respectively to the images minus 2, minus 1, minus 2, minus 2 and 0, minus 2 as shown below. Now state the name of this transformation. Looking at the transformation, you see that PQR is mapped onto P prime, Q prime, R prime. That is, the shape becomes smaller. In this case, it's an enlargement. Somebody may ask, why is it an enlargement? Meanwhile, the new shape is a smaller one. This type of enlargement has a negative scale factor. It means that some sort of a reduction. So students can equally say that this is a reduction, which should be okay. So it's an enlargement with a negative scale factor. And B, find the matrix of transformation, that is T, given that it's a 2 by 2 matrix. We have to just use the points here and work out this matrix. For example, we can start with the point R. I like to use R because some of its coordinates are 0. So T maps R to R prime. So if the matrix T is A, B, C, D, mapping the point R, which is 0, 4, to R prime, which is 0, minus 2, when we expand, we'll have 4B's to be equal to 0 and 4D's to be equal to minus 2 from matrix multiplication. And from there, our B will be 0 and D will be equal to minus a half. Now we have just the values of B and D. So we have to use another point equally. We can use now Q or P. Let me use a Q. T maps Q to Q prime, and that will give us, we already have the values of B and D, so I will just replace them there. And when we do this substitution, we will have 4A's to be equal to minus 2, and the 4C's minus 2 to be equal to minus 2. Here equally, you have C to be 0 and A to be equal to minus a half. Therefore, our transformation matrix T is actually given by minus a half, 0, 0, minus a half. Another student can give it as minus a half into 1, 0, 0, 1, where the scalar or the factor is minus a half, indicating a reduction. If Q prime is reflected on the line y equals 0, find the image Q prime prime of Q prime. Just looking at the diagram, since they set state, the image, you can just look at the diagram and we state from there. So we move on to our Q prime. Our Q prime is at the point minus 2, minus 2. The line y equals 0 is the x-axis. And so when we reflect on this x-axis, the image will be at the point minus 2, 2. The x value becomes positive. So the image is at minus 2, 2. That brings us to the next question. Question 7. We have this figure and A. Name the figure inside the circle. Well, this figure inside the circle is a cyclic quadrilateral. Cyclic quadrilateral. Calculate the angles x and y. For us to calculate the angles x and y, we first of all have to look at this triangle very well and see that triangle CDE is an isosceles triangle. Therefore, this angle here at C is 40 and the angle at E is equally 40. Therefore, the remaining angle up there is 180 minus 40, which gives us 100 degrees. Our x should correspond to this angle. Let's analyze. So x plus the angle at D, that is, those are the opposite angles, should be equal to 180 degrees. Equally, CDE plus ADC will give us 180 degrees. These angles form a line. So the ADC is common and the 180 degrees is common. Therefore, x must be equal to CDE. So from here, our x is equal to 100 degrees minus 40 minus 40. And then we can look for the value of the angle y as well. For the angle y, we see that y plus the opposite angle which is found at C, y plus the angle at C, that is angle BCD, is equal to 180 degrees. But the angle at C should actually be 180 minus 40 minus 35. And that angle is actually going to be 105 degrees if you solve. And we can equally come out with two equations, 3 and 4. Y plus the angle at C is equal to 180, and 35 plus 40 plus this angle at C is equal to 180. Now it's that the BCD is common and the 180 degrees are common, so Y should be equal to 35 plus 40, giving us 75 degrees. C, determine the length L. Determine the length L from circle theorems. You know that the length L, that's from A, this distance A to E times D to E should be equal to EC times EC. So CE squared should be equal to DE times AE, and our age is equal to L. When you put it into this equation, you will have 36 squared to be equal to 4 times 4 plus L. Note that since this triangle is an equilateral triangle, the side DE is equal to 4 centimeters. That will give us the value of L to be 5 when we solve. Question 8. At 7:15 a.m., a boy at the top of a cliff 2,000 meters above sea level sees a boat at a point A at an angle of depression 15 degrees, as you can see on this diagram I've drawn. And 5 minutes later, he sees the boat at an angle of depression of 30 degrees. This is the angle of depression of 30 degrees. At point B now, the boat has moved from point A to point B. Calculate the distance AB to one decimal place. So we have two triangles here which you can work with. The triangle OBP, in which one of the angle at P is 60 degrees, and the triangle OAP, in which the triangle at P here is now 75 degrees. And from SOHCAHTOA, we will have tan 75 degrees to be equal to OA on 2000, giving us OA to be equal to 2000 times 75 degrees. What are we actually doing here? To look for OB, we know that OB can be given by distance from O to A minus the distance from O to B. So that's what we are doing. AB is equal to OA minus OB. So we are looking for OA and for OB. When you get the difference, that will give us AB. Equally, using the other triangle OBP, the angle there is 60 degrees, and tan 60 degrees will be equal to OB over 2000. That gives us OB to be equal to 2000 tan 60. And our AB now will be equal to this OA, which is 2000 tan 75, minus 2000 tan 60, which is OB. And this difference on calculator will give us 6,652.8 meters. So that's the distance AB. In working with your calculator, make sure, because this is a mistake students make, your calculator must be in degrees. Always check, you will see a small DEG up. If you are using purple calculator, if you are using the other one, you equally see a D, some sort of D in a square. And make sure that you don't make this mistake. Always check if your calculator is in degrees. Now the B part of the question says we should look for, calculate the speed of the boat. Calculate the speed of the boat. So normally the distance that we have for AB, it moved from A to B, we had 6,652.8 meters, and you have been told that the boat took 5 minutes. Normally you have to convert these minutes to seconds. That will be 60 times 5, and the speed will be this distance divided by time. That gives us 22.2 meters per second. So the boat was actually running at a very high speed. State the difference in the bearings of the boat from the buoy at points A and B. Normally, the bearings were, or let me say, the angles of depression. We can use the angle of depression directly, and the difference will actually give us the difference in the bearing. So since they are not interested in the bearing, but the difference, so the difference will either be 15 minus 30 degrees or 30 degrees minus 15 degrees, since they have not specified in which direction we should start. So the student gives the negative difference okay as well as the positive difference. Question 9, but always try that in such questions the positive difference is actually preferred. Yeah. The triangle OPQ is a right angle triangle in which RS and OP are parallel, given that OR is 2 centimeters and RQ is 1 centimeters and OP is 2 centimeters. State the ratios QS is to SP. So our QS, if you look at QR and RO, the ratio is 1:2. Therefore, the ratio of QS is to SP will equally be 1:2, because this triangle is an enlargement of the other one. Equally, the ratio RS to OP, let's look at RS to OP. RS to OP will be equal to, now if you look at the first one, they have given us QS. It's a small distance, and the remaining distance is SP. This first distance is 1/3, or let me say it's 1 part. This other distance is 2 parts. Now be careful with RS is to OP. OP is a complete distance, so it is the 3 parts, and this other one is just RS is just 1 part. That's why the ratio here is now 1:3, unlike with this other one where it is 1:2. Take note about this one. B part of the question, calculate the area of triangle QRS. This one can be done in many ways, and to calculate the angle of QRS, I can just use the ratio. That will give me, the triangle is a right angle triangle, so I'll take half base times height. That's half. The base should be 1/3 of this side. I'm using the scale. 1/3 of OQ times 1/3 of OP. That will give me 1/3 squared centimeters. Or another student can just take 1 centimeter, that is RQ, times 1/3 of 2, which is 2/3. So 2/3 times, so 1/3 of 2/3, that is going to give us that is 1/3 times 2, which is 2/3. Now times 1, that gives us 2/3, and then since it's a triangle, we take a half of it, that is going to give us 1/3 squared centimeters. The C passage, you calculate the length of PS to 1 decimal place. PS to 1 decimal place. To calculate PS, we actually need to know the length of PQ. So the first thing we'll do is calculate PQ. PQ here will be equal to, since it's a right angle triangle, the sum of squares of the other 2 short sides is equal to the square of the hypotenuse, and that will give us 2 squared plus 3 squared, that's the total length, should be equal to h squared, that's PQ squared, and our PQ will be √13. Now our PS is 2/3 of this distance, so we have 2/3 of √13. But they said to give the answer to 1 decimal place, so our answer is 2.4 centimeters. D, find the value of the angle RSP. RSP. Know that RSP plus RSQ give us 180 degrees. So here I'll actually first of all need to calculate the angle RSQ, that is the angle at S, and this is going to give us angle at S. Let me bring it down a bit. So this will give us the angle RSQ, that's RSQ, will be equal to tan inverse of opposite, which is 2. The opposite which is 3 over the adjacent, which is 2. That was tan inverse of 3 on 2. Note that the angle RSQ is the same as the angle OPQ. So we can use the dimensions of OPQ to calculate. So that gives us this total distance. 3 on 2. Tan inverse of that gives us 56.3 degrees. And from here, now that we have our RSQ to be 56.3 degrees, this remaining angle RSP will be 180 degrees minus this value, and this gives us a value of 123 degrees. That gives us 123 degrees. Question 10. In question 10, we have this figure. In the trapezium ABCD, AB is 12 centimeters and BC is 30 centimeters. And we are told equal that BC is 2 times AD. So AD should normally be 15. So the first thing is to state the radius of the circle. Since this line at AD and BC touch this circle, and these are at right angles with the line AB, therefore AB should normally be the diameter of this circle, and the radius will be just AB, which is 12 divided by 2, giving us 6 centimeters. Calculate the area of the shaded portion. Area of the shaded portion will be the area of this trapezium minus the area of this circle. And the area of trapezium is half the sum of the parallel sides, that is A plus B times the height, minus the area of the circle, pi radius squared, or pi squared radius. That gives us a half into 30 plus 15 times 12 minus 22 on 7 times 6 times 6. And simplifying gives us a 156.86 centimeters squared. Question 11, solve for x in the following. So in this question 11, we have an inequality. The first thing is to know that this is an inequality, and since it's an inequality, we are going to treat it as such. So this is actually a quadratic inequality, so we can solve by testing regions. So actually the boundaries here are x equals minus 1/3 when you equate to 0, and x equals positive 2. So you have to test which region will satisfy this inequality, because the solution to an inequality is a set of values. So when we test between minus 1/3 and 2, you can take a number like 0 and put inside here. You have, if x is 0, you have 0 plus 1 is 1 times 0 minus 2 is minus 2. This product will give us minus 2, and minus 2 is not greater than 0. So this region in between is the wrong region. When we test above 2, take for example 3 and put the first bracket to be positive and the second one will be positive. Positive and positive is positive, so it satisfies because it's greater than 0, and equally from below. So our solution set will be x is strictly less than minus 1/3 union x is strictly greater than 2. The second one, which is a logarithm, log 100 is equal to 0.5 to the power 2x plus 3. When you see a equation like this, the base of the log is not written, it means that the log is 10. And log 100 can be written the same as log 10 to the power 2, or log 100. Normally on a calculator, log 100 will give you 2. And here, since log 100 is equal to 2, left hand side will now be 2, and the right hand side minus, alright, 0.5 is the same as 2 to the power minus 1, or 2 to the power minus 1 is the same as 0.5. So we have 2 to the power minus 1 all raised to the power 2x plus 3 from third laws of logarithm of indices for the powers. And when we expand, we have 2 to the power minus 2x minus 3. This will be equal to the left hand side, which is 2. Now the bases are the same. On the left hand side, since it's just 2, it means 2 to the power 1. The powers must be the same because there's an equal to sign there. So 1 is equal to minus 2x minus 3, and x will be equal to 2. Question 12, Dr. Miles and his friends are on a pilgrimage to Mater Redemptoris Njangma in the city of Bamenda. While going, they trekked at a steady speed of v kilometers per hour, and the journey took them 3 hours. On their return, they were very tired and decreased their speed by 1 kilometer per hour, and the journey was 1 hour longer. Find the value of v. What we have to note here is that the distance from where they started to this pilgrimage is the same as the distance when they are coming back. So we are going to use that as a key. So the distance, let's call that distance d. Since we're traveling at steady speed, means their distance covered, that distance is equal to speed times time. And that gives us 3 kilometers per hour times v. On their return, they still cover the same distance, d, but they now reduce their speed by 1. So their new speed is now v minus 1. And they took 4 hours. So 4 into v minus 1 should be equal to the same d. Now equation 1 and equation 2 are equal. And 4 into v minus 1 equals 3 v's. And v will be equal to 4 kilometers per hour. That is their speed in which they used in traveling. Question 13. In question 13, we have given the diagram below, find the values of the angles x and y. Looking at this diagram, you can see that these two lines, the one from above, these horizontal lines are parallel. You can see the arrows. And since they are parallel, this line that cuts, this diagonal line moving from left to right here, is actually a transversal of these two parallel lines. And for this reason, this angle 3x must be equal to this angle 5x minus 20. These two angles are the same. So we have 3x to be equal to 5x minus 20 and 2x to be equal to 20, giving us the value of x to be 10 degrees. Then for angle y, this triangle here with values 2y's, 4y's, and 5x minus 20, the sum of all these angles will give us 180 degrees. But we already have x to be equal to 10 degrees. So 2y's plus 4y's plus 5 times 10 minus 20 should give us 180. We will have 6y's to be 150 and y will be equal to 25 degrees. State the relationship between the angles 3x and the angle 5x minus 20. Now these two angles are alternate angles. These two angles are alternate angles from your grade 7 work or form 2 work. These angles are alternate angles. Question 14. The Cartesian product AB equals 1, 1, 1, 5, 3, 1, 3, 5, 7, 1, 7, 5. Find the Cartesian product BA. To have BA, just swap the positions of each of those elements there. So 1, 1 remains 1, 1. 1, 5 becomes 5, 1. 3, 1 becomes 1, 3, and so on. We are until 5, 7. These are elements of set A. According to the equation, the Cartesian product AB means the first element must be from set A. So let's look at all of the first elements. You have 1, 1, 3, 3, 7, 7. But we cannot write them twice. So you just have 1, 3, and 7. Those are the elements of set A. How many proper subsets has set A? Now the number of proper subsets in any set is given by 2 to the power n. And of all those subsets, 2, that is the empty set and the set itself, are called the improper subsets. So the number of proper subsets should be equal to 2 to the power n minus 2. And our n here is the number of elements, which is 3. So 2 to the power 3 gives us 8 minus improper subsets, and there are always just 2 of them. So 8 minus 2 gives us 6. There are 6 proper subsets. In the network shown, in how many ways can we move from x to y? Well, the equation intended to ask, in how many ways can we move from 1 to 5 if you represent that AB as a network, and there will be just one way. So the item is missing. That's not of our concern. We just leave it. Question 15. Question 15, we have in triangle OAB, x is the midpoint of OA, and 4OY is equal to OB. If OA is equal to the vector A and OB is equal to the vector B, sketch the diagram and find the value of the vector xy in terms of A and B. So to move from x to y, you have to move from x to O and from O to B. But from x to O, you are moving the opposite direction of A. And x to O is a half of this distance, so it's a minus a half A. And now to move from O to B, to move from O to Y, from O to Y is 1/4 the distance from O to B is 1/4. Because you say 4 times OY will make OB. So this distance is 1/4. So plus 1/4 B. Now be sure that BA is parallel to OX plus 2OY. Normally the equation wanted to say OX minus 2OY. Anyway, let's work and see. Since the equation is like this. So our BA normally is equal to A minus B. That's what we have. And our OX plus 2OY is equal to a half into, note that 2OY should be equal to a half of OB. So a half plus a half A plus a half B. That's just equal to a half into A plus B. And since BA is A minus B and this other one is half into A plus B, the B's values are different. So we cannot show that one is parallel. We cannot show that they are parallel. If we could show that they are parallel, or one is a scalar multiple of the other, and then we have proved that they are parallel. But one is not a scalar multiple of other, so we say that they are not parallel. Note, it's not all the time that when it show that something is parallel, it actually mean it is parallel. At times it's show that they are parallel when they are not parallel at all. And the last part we have, if OB is equal to 15, state OY. Now we know that OY or 4OY is equal to OB from the equation. Therefore, OY will be equal to 1/4 of OB. So if OB has a magnitude or modulus of 15, then the magnitude or modulus of OY should be 1/4 of that value, which is 3.75. Thank you so much, and stay tuned to the second set, which is made up of the 4 other questions. Please don't forget to subscribe and click on the notifications so that whenever we upload any material, you will not be left out. You will be notified. Share and leave your comments. If there are errors and other things, always remind us. Like with the first part of the question, you saw that there was some sort of analysis, but always leave your comments and share and leave your likes. Thank you so much, and welcome to the GCE Math panel.